Hi everyone, welcome here. So previously we have learned one of the sorting techniques that is called a bubble sort, and today we are going to discuss what is a linear search. Then we will discuss another sorting mechanism that is called a binary search. So first thing first, let us understand linear search. Now first of all, to before writing a program, we have to understand how linear search works. Before that, I have written a simple program to get a random list. I have used a random module and rand int function 120. So this will generate any random number between 1 to 20. You can see here is my output, and if I enlarge it, you can see I have generated 10 elements, and these all are in random order. So this is a pretty simple, straightforward program to get the list. Okay, now what you can do, you can simply copy this list and just copy it here. That is perfectly fine. Now you do not need this code anymore. Okay, so I'm also going to delete this. So this is our simple list, which is not in order. Now what we are going to do, we are going to search an element. For example, let's say 7, 10, 5, whatever, right? So what we are going to do, we are going to ask a number from the user. First of all, let's say find find is our any element that is to be converted into an integer. Then we are going to have an input, and let's enter any number to be searched. Okay, now what we are going to do, we are going to match this number with the first element, then second element, third, fourth, fifth, sixth, so on. And when we find a match, we are going to simply stop it and say we found that element. Okay, that's pretty simple. Just we can use a for loop for this. I in let's say lst. So one by one we are going to have element in I, and then we just need to compare this I with the find, and let's print found. Okay, now to get the position, you need to have a counter. Let's say counter is equals to 0, and whenever we are going to fetch one element, I'm going to increase the value of a count by 1. Okay, so when we are having the first element, that is 7, the value of a count is 1. 0 plus 1 1. For 20 it is 2, 3, 4, and so on. So at let's print the count. Okay, so this will print the count position, and then just use a break statement to terminate the following. That's perfectly fine. And if okay, that's perfectly fine. Let us execute this piece of code till now here, and we will see what is the drawback of this program later on. Okay, let's run this program and check it out. So my list is already generated, and now I'm going to find let's say 6. Okay, click found at 4. Let us see whether this 6 is present at 4. 0 1 2 3 and 4. Okay, actually 1 2 3 and 4, since we have increased the counter from 1. Okay, now what if I specify any value which is not in the range or not in the list, let's say 100, and you will see nothing. Okay, so this is the drawback. It tells when it founds, but it doesn't tell when it doesn't found. Okay, so what we are going to do, we are going to have a variable called found is equals to, let's say, false, and when this statement is executed, when we found the element, we can say found is equals to true. Okay, so we are just changing the flag variable, and let's say if found is equals to the initial value, that is false, then we can always print sorry I element doesn't exist. Exists. That's perfectly fine. Wait a minute, my phone is ringing. Okay, now let us try and execute this piece of a program and check it out. So let's the number be 123, which is not in the list, and it says sorry, element doesn't exist. I hope you got the concept. Now, why I should be writing this statement? Because initial value is false here. This is acting as a flag variable. So if this statement is not executed, that means your value for found will be false. And we are just exactly checking that only. And hence we can straight away say that we found the element or we doesn't found the element. Okay. Now, if you want to count the number of instances, for example, you can see we have 6 two times and 7 two times. That's pretty simple. Instead of a flag uh, value, you can simply say found is equals to 0 and increase the found whenever you found the element. Okay, and if found is equals to 0, that means element doesn't exist, which is the initial position or initial value. Else we can say print number of times the element present is, let's have a found. Okay, now let us execute this piece of a code and check it out. Okay, 6. Now you can say it is present 4 times. Why it is present 4 times? Okay, number of times the element is present at 1, because 0 plus 1 is equals to 1 and it should be 2. Let's see, plus 1 found 0, it should be okay. We should not use break. Now if try to execute this, you can see found at 4 and found at 6, so 2 times we found it. And if you execute it for, let's say, 13, it is present only 1 time, so found at 10 and 1. If you want to print only this, you just have to skip this point, this statement, and execute it, let's say 6. Now you will be getting only the count. Okay, so this is how our linear search works. That's why it is called a linear search. You know why? Because we are going to hit or access each and every element in a sequence. That's why it is called a linear. Okay, without any branching. Okay, so this is one of the searching which is really very important, and this searching is done when the list is small and unordered. Or if you have unordered list, you only have to have a linear search. Okay, and other search, let's say, that is called a binary search, is done for the list when we have a shorted list. Okay, that's end of the video. Hope you liked it, and bye bye, see you next time.